5,000 years ago, the Australian outback wasn't quiet. Something came screaming out of the sky, brighter than the sun, louder than thunder, and hot enough to turn solid rock into liquid metal. It didn't leave a single scar. It shattered the ground into pieces, punching a cluster of holes into the desert as if the land itself had been struck by a pickaxe. For thousands of years, people walked around this place without touching it. Stories were told about fire falling from the sky, about something evil and burning that poisoned the earth. Long before scientists arrived with maps and instruments, the landscape was already marked as dangerous, forbidden, and not meant to be disturbed. What makes this strange isn't just that a meteorite hit Australia, it's that this happened so recently that human beings were almost certainly watching when it did. This wasn't dinosaurs, this wasn't deep time, this was human time. And yet, until the 20th century, no one outside the desert had any idea this had happened at all. This is the story of the Henbury Impact, one of the youngest meteorite strikes on Earth, preserved in plain sight, hiding in the middle of Australia. 5,000 years ago, Central Australia looked much the same as it does today. Red earth, sparse vegetation, long empty horizons, the kind of landscape that feels ancient and unchanging. But on one ordinary day, that calm was shattered by something arriving from space. An iron meteorite, older than the Earth itself, entered the atmosphere above what is now the Northern Territory. It didn't drift in gently, it arrived at tens of thousands of kilometers per hour, heating instantly, tearing apart under extreme pressure, and exploding just above the ground. What followed wasn't a single impact, but a violent chain reaction that slammed into the desert with overwhelming force. When the dust settled, the land had been permanently altered. Instead of one crater, the ground was punched into a cluster of circular scars. Sharp-rimmed bowls blasted into solid sandstone and desert sediment. Rocks were overturned, shattered, and flung hundreds of meters. Iron fragments were scattered across the surface, still hot, still dangerous, still radiating the violence of what had just happened. This wasn't ancient history. This wasn't a distant geological abstraction. This was an event that happened within the span of human memory. The site we now call the Henbury Crater Field sits about 130 kilometers south of Alice Springs. Today, it looks quiet, still, almost peaceful. But once you walk among the craters, it becomes obvious that something catastrophic happened here. The ground is broken in a way that doesn't match erosion, volcanism, or tectonics. The craters are too sharp, too clean, too sudden. There are around a dozen confirmed craters spread over roughly 1 square kilometer. The largest is about 180 meters across and more than 15 meters deep. Others are much smaller, only a few meters wide, but still unmistakably impact features. Together they form a pattern that tells a very specific story. A meteorite that fragmented mid-air and struck the ground in pieces. For a long time, Western science had no explanation for this place. When Europeans first encountered the site in the late 19th and early 20th century, they had no framework for understanding it. Meteorite impacts weren't yet widely accepted as geological forces. Circular holes in the desert were usually explained away as volcanic features, sinkholes, or erosion oddities. But the local Indigenous people already knew better. Long before scientists arrived, the Henbury site was avoided. Oral traditions warned that it was a place where a fire devil came from the sun and burned the land. Stories spoke of heat, destruction, and danger. The craters weren't just physical features, they were reminders of something catastrophic and deadly. What makes this extraordinary is that modern dating places the Henbury Impact at around 4,200 years ago, with a margin of error that still keeps it well within human habitation of Australia. In other words, these stories weren't symbolic, they were memories. Somewhere in deep time, people watched the sky light up, heard the roar, felt the shockwaves, and saw the ground explode beneath their feet. From a geological perspective, Henbury is one of the youngest confirmed meteorite impact sites on Earth. Most impact craters we know are either heavily eroded or millions of years old. Henbury is different. Its features are crisp, its rims are sharp, its ejecta is still visible. In some places, meteorite fragments can still be found lying on the surface, and those fragments tell us exactly what hit here. The meteorite was composed primarily of iron and nickel, minerals that don't originate on Earth's surface in that form. These are remnants of a differentiated planetary body, likely the core of an ancient asteroid that was shattered early in the solar system's history. That means the object that struck Henbury formed billions of years ago, orbited the Sun for unimaginable lengths of time, and then ended its journey in the Australian desert. When it entered Earth's atmosphere, it didn't survive intact. The extreme heat and pressure caused it to break apart before impact, producing multiple explosions and multiple craters. This explains why Henbury isn't a single bowl, but a crater field. The energy released would have been devastating on a local scale. Anyone standing nearby would not have survived. The blast would have generated intense heat, shock waves, and flying debris. Even at a distance, the event would have been terrifying. A fireball brighter than the sun, followed by thunderous explosions and rising clouds of dust and smoke. Yet, unlike larger impacts that alter climate or trigger mass extinctions, Henbury was small enough to be localized. It scarred the land, not the planet. That balance between cosmic violence and human-scale impact is what makes Henbury so compelling. Geologically, the craters are cut into sedimentary rocks of the Amadeus Basin, a vast Proterozoic basin filled with sandstones and other sediment laid down hundreds of millions of years earlier. The meteorite punched straight through these rocks, compressing, fracturing, and locally melting them. In some places, impact breccias formed, chaotic mixtures of shattered rock fragments fused together by the force of the explosion. These features are textbook indicators of impact processes, and today Henbury is used as a reference site for understanding small-scale impact mechanics. But what Henbury really represents isn't just geology, it's perspective. We often think of meteorite impacts as things that belong to the distant past, dinosaur-ending catastrophes, ancient scars hidden beneath jungles or oceans. Henbury reminds us that Earth is still part of a dynamic solar system. Space doesn't stop interacting with our planet just because humans exist. 5,000 years ago, the sky delivered a message, and Australia received it. What's even more striking is how easily the site could have been missed. Central Australia is vast, empty, and remote. If the craters were slightly older, erosion might have erased them. If they were slightly smaller, they might have never been recognised at all. Instead, they sat quietly in the desert until science finally caught up with the stories. In the 1930s, proper investigations confirmed the meteoritic origin of the craters. Iron fragments were collected, shock features were identified, and the mystery was solved, not by overturning Indigenous knowledge, but by aligning with it. Today, the Henbury craters are protected as a conservation reserve. Visitors can walk among them, peer into their bowls, and touch the rocks that were thrown aside by an object older than the Earth itself. It's one of the few places on the planet where you can stand inside a meteorite impact crater that formed within the span of recorded human history, and that's the unsettling part. Nothing about modern life protects us from this happening again. Objects of this size still pass near Earth. Most burn up harmlessly, some don't. Henbury wasn't a once-in-a-billion-years event. On geological timescales, it was routine. The only difference between then and now is awareness. 5,000 years ago, people watched the sky and survived with stories. Today, we watch the sky with telescopes and satellites, mapping potential threats and calculating probabilities. But the message is the same. Earth is not isolated. Australia is not immune. And the desert remembers. And it all began with a meteorite that hit Australia, not in myth, not in prehistory, but in a moment close enough that someone, somewhere, was there to see it fall. I hope you found this as interesting as I did, and as always, thanks for watching. Before I end this video, I'd like to give a big shout out to my Patreon and YouTube members. Thank you so much to everyone that helps to support this channel.